Hey everyone, Math 103. This is the second video for the graphing project. If you haven't seen the first video, please start with that one. Now in this one, with some of the data sets, we're going to be asked to find a maximum point. If you have a data set that doesn't have a maximum, then you're just given a point to use. But this data set, for the example, does have a maximum. So point 1812 is the maximum plant growth. So how do we know that's the point? Okay, we're looking for the maximum height here. Height is measured on the vertical scale, so we want the point that is farthest up on the vertical scale, and that is point 1820 or 1812. So now the coordinates of this ordered pair, if we write an ordered pair, the first coordinate we write is its position on the horizontal axis, and that is at 18. And the second point is its position on the vertical axis, and that is at 12. So the ordered pair would be 18, 12. All right, now we're going to express the relationship between the quantities at this point. In order to write precisely the meaning of one of these points, we have to have the independent variable with its units, the dependent variable with its units, and then some indication of the cause and effect relationship between the two quantities. So some example sentences, a plant that was fed 18 milliliters of fertilizer. All right, so we got that it was a plant. We've got the quantity on the horizontal axis, 18. We have the units, milliliters, and we say what it is, fertilizer. So there's all the information for that piece. Grew to be 12 inches tall a month later. So we've got the fact that we're waiting a month. That's described in the paragraph. And we got that the plant grew to be 12 inches tall. And if you look at the sentence, the plant that was fed 18 milliliters of fertilizer grew to be 12 inches tall a month later. So there is a cause and effect relationship implied in that sentence as well. So we got all three pieces. And now we're going to write a range. So we're going to write a range for the values of the independent variable such that the dependent variable, the height, meets some criteria. And the criteria we're looking for in this one is, did the plant grow to be 10.5 inches tall? So first thing we're going to do is create a vertical line here at 10.5. So what we're looking for is the amounts of fertilizer that will produce at least 10.5 inches of growth. So all of these plants were at least 10.5 inches high. So we start here at 10. This is the point 10, 10.5, and if you look at the table, I'll show you exactly what these points are. My graphing is fairly approximate. So the first one, 10 and 10.5. So that gives us the starting point where the plants tend to be above 10.5. And then at the ending, we got 24. So here at 24, 10.5. So anything less than 10, we've got less than 10.5 inches of growth. And anything greater than 24, we've got less than 10.5 inches of growth over here. It's only between those two values where we get more than, or at least, 10.5 inches of growth. So now we're going to write that range using interval notation. So it's asking for the range of fertilizers. Here's the range of fertilizers, 10 to 24. It includes 10, because 10 is right on 10.5. So that means we're going to use the bracket. And 24 is the endpoint, so there's our range of values, 10 to 24, that produce at least 10.5 inches of growth. Next up, we're going to take a piece of this graph and find the slope of the line connecting these points. So if you look at the points between 28 and 36, they're roughly in a line. We could draw a line down through it, and it's pretty close. So what we're going to do is calculate the slope of this line going through the point at 28 and at 36. So those are the 2 points we're going to use to find the slope. Now before I start calculating these things, you may not need to calculate the slope for your project. There is either a slope, there is a growth rate, or there is a horizontal asymptote. So you'll have one of those 3 calculations to do. So if you'd like, you can skip forward to the part of the video that talks about your calculation. All right, so our 2 points then. Calculate the slope. We've got one here at 28. I'm just going to call that point 1. And fertilizer is 28. Height is 9.3. So there's our first point. And the second one, I'm going to call that point 2. And for point 2, we're going to do 36 milliliters and 3.1 for the height. You may have heard slope being described as rise over run. Which is a good way to think about it because we're working with graphs. So rise is how much does the vertical position change between these 2 points. So between here and here, how much are we going up or down? The run is how much we move in the x direction. So between these 2 points, how much are we moving to the right? And the difference is found by subtracting the coordinates for the 2 points. So the rise, we're talking about the y coordinate, the second coordinate, 9.3 and 3.1. All right, before we do the actual calculation, I want to do a couple of sample calculations. So for the first one, we're going to find the slope of the line between the points 2,8 and 1,4. Now the rise, as I said, was the change in the dependent variable. That's the one on the vertical axis. And that is the second coordinate. Now it's essential that we subtract in the same direction. All right, if I'm going to subtract this coordinate from this one, then I'm going to subtract, if I'm going to subtract 4 from 8, I'm going to subtract 1 from 2. All right, use the same direction. So we're going to do 8 minus 4 on top. And then the bottom, that's the run, so that's the x coordinate, so 2 minus 1. So the slope between the points 2,8 and 1,4 is 4. All right, your turn. Find the slope of the line through the points 3,7 and 0,1. All right, the rise will be the change in the y coordinate. So that'll be 7 minus 1. And the run will be the change in the x coordinate, so that's 3 minus 0. So that gives us 6 over 3, which is 2. So the slope of that one is 2. Okay, back to the project example. So the rise, that'll be a change in the y coordinates. So we can subtract in a consistent direction. So I'm going to subtract 3.1 from 9.3. So 9.3 minus 3.1. Now the run will be the change in the x coordinates. Now I subtracted 9.3 minus 3.1, so I have to do 28 minus 36. So we get 6.2 divided by negative 8. And when we divide that out, we get negative 0.775. All right, so we got some number. What does that mean? All right, now we're going to write the meaning of the slope in the context of this problem. Talking about fern height and the amount of fertilizer. All right, so slope is a rate of change, and it's talking about the rate of change of the fern height when we change the amount of fertilizer. So this number tells us how much the fern height will change when we increase the amount of fertilizer by 1 milliliter. So some example translations. If the amount of fertilizer increases by 1 milliliter, then the 1 month plant height decreases by 0.775 inches because it's negative. Negative means we have a slope. It's going down to the right, means the number, the fern height is getting smaller as we increase the fertilizer. So as you can see, after we get past this, we're over fertilizing. So more fertilizer means actually less growth over here. All right, another way of stating this, the 1 month plant height decreases by 0.775 inches as the amount of fertilizer increases by 1 milliliter. All right, we've got that cause and effect relationship there, and we've got both quantities and both units. So make sure you've got all of those in the translation. Another one, the rate of change of the plant height is negative 0.775 inches per 1 milliliter of additional fertilizer. So a couple different ways of stating the rate of change there. All right, next topic is going to be the growth rate or decay rate. So growth or decay rates are decimal values that are expressed as a percentage. So you say something is growing at 5% per year or something like that. So with growth or decay, we've got some value at some quantity, and it's either going to rise, grow, or shrink, decay. And it's going to do this at a specific percentage value every time period. So we're going to use this formula for calculating the growth or decay rate. So we need a starting value, an ending value, an n, which is the number of time periods. And then once we calculate all this out, we're going to subtract 1, and there's our rate. So for example, we have a social scientist tracking the decline in population of a town. The independent variable is the number of years since the start of the study. The dependent variable is the town's population measured in thousands of people. Find the decay rate between the points 3, 23.1, and 7, 19.6. So here's our 2 points. So the first number is time, all right, that's our independent variable. And the second number is the town's population, that is our dependent variable. So when talking about the starting and ending values, we're talking about the dependent variable, so it's going to be these two. All right, this is an earlier time, this is time 3, so this is our starting value, 23.1. Whatever values with the earlier time, that's our starting value. Ending value, later time, 19.6. Now we need to find n. So that's how many time periods? Well, that'll be the difference between the last time period and the first time period. So 7 minus 3. So n. So n is going to be 4. And keep in mind, this exponent, it's not n, it's 1 over n. So we're going to, our exponent will be 1 over 4. All right, so there's all our values plugged in. Dividing these two, we get 0.85 to the 1/4 minus 1. Calculating that out, we get negative 0.04. So there's our decimal value. Now we want to convert this to a percent. So we'll take that decimal, move it 2 places to the right. And we get a negative 4% decay rate. All right, so what we want to do now is write the precise meaning of that number. So what this number represents is how much population the town is losing each year. So you could say something like the town's population decreases by 4% per year. Another way of saying that, the town is experiencing an annual population decline of 4%. So in these sentences, notice I'm saying what we're talking about, a town's population. Got the number, growth rate, and showing that negative means decline. So something in each sentence talking about losing residents, population decline, population decreases. All right, your turn. An investor in a certificate of deposit, otherwise known as a CD, is calculating the growth rate of the investment. The independent variable is the number of years since the CD was purchased, and the dependent variable is the value of the CD. Find the growth rate between the points 2, 52.53, and 8, 60.92. Our first thing we're going to need is the starting and ending values. So the starting value is at the earlier time, 2, so it's 52.53. And the ending value is time 8, so 60.92. Now I need to calculate n. N is the difference between the times, so 8 minus 2, or 6. So that's 1 over 6 is the exponent, and we'll subtract 1 from that. So calculating this out, we get 0.025. Now converting this to a percent, move the decimal 2 to the right, and we get 2.5%. So now what does this value mean? Well, we've got the value of a certificate of deposit, so we need to mention that. And it's positive, so that means the money's growing. So the value of the CD increases by 2.5% per year. The value of the CD grows by 2.5% per year. Or every year the CD's value becomes 2.5% larger. So something like that. The last type of calculation involves horizontal asymptotes. So some graphs are going to become nearly horizontal as we go off to the right. And this is called having a horizontal asymptote. An asymptote is a horizontal line that our graph will approach and get closer and closer and closer to, but never touch. Now, in order to find the equation for the horizontal asymptote, what we're going to do is we're going to take our formula for the graph and we're going to plug in larger and larger values to see where this thing goes as we go way out to the right on the graph. And that'll give us a clue as to what the horizontal asymptote is. And then we're going to use values from within the problem to have a guess at what the horizontal asymptote is. So first example, got a college student has a business selling t-shirts. Cost to produce one t-shirt is given by the formula. C equals 550 plus 7n over n. And where C is the cost of one t-shirt, of just producing one. And N is the number of t-shirts produced. So we're going to produce a certain number of t-shirts, and depending on how many we produce, there will be a certain cost associated with producing just one of them. All right, now to find the horizontal asymptote, the cost is calculated for large numbers of t-shirts. So we're going to do 50, 100, and 200. So I'm going to plug in those values for N, because that's the number of t-shirts. And this symbol means the cost of 50 t-shirts. This parentheses does not mean multiplication. It's just a notation. Okay, so now we're going to plug in 50 for N, so we got 550 plus 7 times 50 over 50. And calculating that out, that gives us 18. C of 100. We're going to plug in 100 for the N's, and that gives us 12.5. And when we were making 200 t-shirts, plug in 200 for N, and that brings the cost per t-shirt down to $9.75. So as we produce more t-shirts, the cost of just one of them keeps going down. Now we got to look through the formula here and see if we can see a number that we think that this is trending toward. What's this number going to? Well, there's only two numbers in the formula. There's 550 and 7. So is this approaching 550? No, it's going down, so it's going away from 550. Now, this does look like it might be approaching 7. So that's the best guess for a number. If we keep increasing the number of t-shirts we're making, eventually we're going to get close to 7. So that would be the horizontal asymptote. So if this were our curve here, you can see as we go further and further to the right, we keep getting closer to this number, and we're going to guess that this number is 7. So the equation for this line here, this dotted line, is you take the independent variable, the dependent variable, the cost, right? C is dependent upon the number of t-shirts. So C is the dependent variable, and we're going to set that equal to our number. So C equals 7 would be the equation for that horizontal line. So that's what you want your equation to look like. Your dependent variable equal to some number, and that will be a horizontal line. And there's your asymptote. Okay, so in the context of this situation, what does this value represent? So we're going to put this idea into words. And the idea here is the asymptote. This represents the number that our equation gives if N is really large. So in other words, if we sell a lot of t-shirts, the cost of each t-shirt is going to be approximately $7. And that's the meaning of the horizontal asymptote. It's what happens when our independent variable, the number of t-shirts, right, that's what's being graphed here on the independent axis, on the horizontal axis. This is the number of t-shirts. So we're going all the way off to the right, and that means we're producing a lot of t-shirts. So what happens when the independent variable gets really big? Well, what happens is our dependent variable, C, approaches 7. Your turn. Some friends are renting a large hall for a party and are figuring out how much to charge each guest. The cost per guest is given by the formula C equals 300 plus 4n over n. And C is the cost per guest, and n is the number of guests. So to find the horizontal asymptote, the cost is going to be calculated for large numbers of guests. So we use the same numbers as we did over here. 50, So that gives us 300 plus 4 times 50 over 50, and that is 10. So if we have 50 guests, it's going to cost $10 per guest. C of 100, that would be 300 plus 4 times 100 over 100. And that gives us 7. So the price per guest keeps dropping. If we go from 50 to 100 guests, the price per guest drops from 10 to 7. All right, now let's try 200. So 300 plus 4 times 200 over 200, and we get 5.5. All right, so which value from the exercise are these numbers approaching? Well, they're not approaching 300, so they're probably approaching 4. So that means our horizontal asymptote will be the equation C equals 4. All right, so what does this horizontal asymptote mean? Well, we want to answer it in the context of this problem. So we're talking about friends having a party, having guests. And what we're talking about is what's the cost per guest when we have a whole bunch of guests. So n is going to get really big. So if many guests attend the party, the cost per guest will be about $4. And that is the meaning of this horizontal asymptote. N gets really big, the cost goes toward 4. So if we were to graph this thing, it's going to look, all right, we've got C equals 4 here. Here's our asymptote. We're going to have some kind of graph that's going to look something like this, and it's going to come down. As we go off to the right, it's just going to get closer and closer to 4. So the more guests we have, the closer to $4 per guest the cost approaches. All right, that is it for today. If you have any questions while working on this, please do not hesitate to contact me. All right, good luck, everyone.